Design of RCC water balancing tank for Malad village in Pune district. The member of this project are Amle pratik1, Abhay Vikram Singh and Madhurjia Borgon. Internal guide is Ms. Rajapriya Darshini JR, Assistant Professor of Civil, Weltech Technical University, and external guide is Mr. Pradeep Jagtap, Deputy Engineer in Maharashtra Jeevan Pradhikaran, State Government of Maharashtra. The abstract of this project, which consists the Malad village is in Pune district and it does not have any source of water or it doesn't have any storage capacity tank. The population of this village is 5,000 and the Maharashtra state government has started this project under Maharashtra Jeevan Pradhikaran. The water balancing tank will be having capacity of 32 ml liters, and it will have the storage of 2 months. The purpose of this project is to provide the required amount of water to the people and store the water in case of emergency. The need of the project consists the water available at that village is saline due to excessive use of fertilizers in the field, and hence it is not useful for drinking purpose. The population is increasing day by day and the rainfall is less too, and the surface source is not available there. Hence the project is required and the government has started this project to avoid the shortage of drinking water. The canal is in summer season get dry, so there is no regular supply of water. About working site, the village Malad is in Baramati Taluka of Pune district. It is around 120 km from Pune and it consists the population of 4801 people around 2011 calculation. It has the average rainfall of 438 mm. The first step of this project is water source investigation. The three sources we have find out: one is Karaha river, which is polluted, hence we cannot use it for drinking purpose, and another one is Neera river, which is 3.6 km away from the village. It is suitable for storage, but the rainfall is very less, so we can't get the water from Neera river throughout the year. The groundwater storage is available, but due to use of excessive fertilizers, the water is saline, so we can't use it for the drinking purpose. The canal is available, but water is not available throughout the year. Collection of data. The average rainfall is 438 mm. Population is 4801 as per 2001 census and 5635 as per 2011 census. The expected population in 2020 is 7203 people. Daily water demand we have considered as 40 liters per head, and water capacity of the storage tank will be 32 million liters. Daily water demand will be 0.288 million liters a day, and the supply of water will be for 2 months, and proposed tank dimensions are in trapezoidal shape. The estimated cost of the tank with the pump house is 3 crore 26 lakhs 594. The layout of the plan is shown in the next slide, and the dimensions of the tank are shown as A, B and C. A is having 184 meter length, B is having 122 meter length, C is 170 meter and D is 53 meter. The diagram shows is the rough diagram of the footing wall, and the height of the wall is 4.15 meter. Thickness of the wall up to 1.9 meter is 650 mm, and thickness of the wall from 1.9 meter to 4.15 meter is 250 mm. The footing base is 7350 mm, and the Indian standard codes are used are IS 456 2000, IS 3370 1967, IS 875 1987, IS 11682 1985, IS 1976 1979 for steel grade. The materials we have used are cement 43 grade, steel Fe415 steel bars, centering as per the design we have done, and concrete is M30. The design specifications are given. The tank capacity calculation we have done as the expected storage we want is 2 months and the daily demand is 0.37 million liter a day. Capacity required for 60 days is 22.20 mld, and the considering losses it will be 31.7 mld. So total capacity we have calculated is 32 million liter, and the tank calculation conditions we have considered as first one is tank full and no earth outside. The second will be tank empty and earth up to ground level. The bending moment at bottom of wall and the dimension 4.25 meter. Bending moment is calculated as 12794 kgm. The AST we have calculated is 16,302 centimeters square. The another is tank empty and earth full condition. Here the height of earth is considered as 3.9 meter. Bending moment is 4426.09 kgm. Beam will be designed as 250 by 350 mm. The self load of the beam is 218.75 kg per meter. Shear force is 2513 kg and bending moment is 2118 kgm. Provided bottom 12 mm dia bars, and the beam size will be 250 by 350 and 250 by 450. The column size is designed as 250 by 400. The reinforcement details of the wall are shown in the diagram. The A denotes the horizontal 12 mm dia bars at 125 mm center to center spacing and a vertical 10 mm dia steel bars at 175 mm center to center spacing. The B point denotes horizontal 8 mm dia bars at 110 mm center to center spacing and vertical 10 mm dia bars at 175 mm center to center spacing. The grouting is made at 1000 mm from shear key and 25 mm dia bars are placed. The shear key details as the dimensions having 650 by 750 mm. The soil strata piles are applied where the soil strata is soft, and normal footings with shear key is applied where the soil strata is hard. The pile design is shown in the diagram. It is 8 meter deep and at a side of 122 meter piles are applied. The expansion joints are placed at every 40 meters and the material used is a water stopper and a heat launch sheet. In first diagram the red circle denotes the expansion joint, and in second diagram the black color is the heat launch sheet. The concreting and shuttering are done as per the IS code, and the column and beam will be placed for 3 days and vertical walls will be for 6 days and bottom of span will be for 21 days. The side photos are shown in this slide. The next slide will be the floor slab. The major problem we faced is that there will be a leakage under the floor, so geomembrane sheets will be placed with the help of sand layer. It will avoid water leakage and avoid the water losses. Our work contribution is the design of RCC water balancing tank and use of geomembrane sheets on large scale. We have even found the way to avoid leakage from the footing base by using the geomembrane sheets. This is the literature review from Delvin D. Boer. With the change of temperature, the water quality is changed, so we need to study the thermal changes occurring in the water tank. The another one is Isoiki Bachbani and Musanji Fomba. He has studied that the water distribution network should depend upon the size of the tank, and it will be changes according to the type and size of the tank. The third literature review is of Ricciardo Cobaco and Francisco Arengue, Enrique Cabrera and Enrique Cabrera Jr. in 2008. The water storage tank are often considered as an insufficient devices, and it can be improved by decreasing losses and avoid energy losses. We have used this literature review to avoid the water leakages. It is the one of the major loss we faced. These are the references we used. Thank you.